If you've ever had a bad day at work, it's probably still better than Phineas Gage's, because on the 13th of September 1848, a 1 meter long iron bar was blasted straight through his skull, and somehow he survived. Not only did he survive, he accidentally became one of the most famous patients in the history of neuroscience, and for over 150 years, scientists, psychologists, and textbook authors have been arguing over one question. Did this accident really change who he was? Or have we been telling the story wrong? The railway worker who changed neuroscience forever. Today, if you take an introductory psychology or neuroscience class, there's a very good chance you'll hear about Phineas Gage. Usually, the story goes something like this. Iron rod goes through the brain, personality completely changes, and scientists discover the frontal lobe. Simple, memorable. There's just one tiny problem. It's not quite that simple. Over the years, the real story has become mixed with exaggeration, assumptions, and a few myths that are honestly just too good for people to stop repeating. So, today, we're going back to the original reports, looking at what actually happened, what we really know, what we don't, and why this one railway worker helped change neuroscience forever. Meet Phineas. Before becoming neuroscience's favourite case study, Phineas Gage was, well, a railway foreman. Not a doctor, not a scientist, not someone trying to make history. Just a 25-year-old working on the rapidly expanding railway system in Vermont. Now, laying railway tracks in the 1840s wasn't exactly an office job. To make room for the tracks, workers had to blast through solid rock. And here's how they did it. First, drill a deep hole. Then pour in explosive powder, add a fuse, cover it with sand, then use a long iron tamping rod to pack everything down nice and tightly. What could possibly go wrong? Well, quite a lot actually. Because if the powder exploded before you were finished, you were standing directly above it, holding a giant iron spear, which is less than ideal. And this rod wasn't a little spike. The tamping iron was about 1.1 meters long, roughly 3 centimeters in diameter, and weighed around 6 kilograms. Think of a solid iron javelin, except heavier, and significantly less interested in following workplace safety regulations. The accident. On the afternoon of September the 13th, 1848, Phineas Gage and his crew were working near Cavendish, Vermont, preparing a section of railway track. The job was repetitive. Drill a hole, add explosive powder, pack it down, move on. Until one small mistake changed the entire course of neuroscience. While Gage was using his tamping iron to compress the explosive material, the powder suddenly ignited, and the result was catastrophic. The explosion launched the iron rod upwards, straight through Gage's skull. The rod entered beneath his left cheekbone, travelled through the front part of his brain, and exited through the top of his skull. It landed several meters away, and somehow, Phineas Gage did not die. In fact, according to the reports of the physician who treated him, John Martin Harlow, Gage was conscious almost immediately afterwards. Because apparently surviving a metal bar travelling through your brain was not enough of an inconvenience, he also decided to sit upright in a cart and calmly explain what happened. Which raises the question, how on earth was this possible? A brain injury that changed science. To understand why Phineas Gage became so important, we need to understand what scientists believed about the brain at the time. In the mid-1800s, scientists were still trying to answer a huge question. Does the brain have specialized areas? Or does the entire brain work as one general system? Today, this might sound like an obvious question, but back then, neuroscience was still trying to figure out the basics. Some researchers believed that different mental abilities might be linked to different areas of the brain. This idea was connected to a controversial movement called phrenology, which claimed that personality traits could be determined by bumps on the skull. And yes, people genuinely spend time measuring people's heads. Unfortunately, the science was about as accurate as judging someone else's personality based on their favourite biscuit. Phrenology itself was wrong. However, hidden within this incorrect idea was a question that turned out to be surprisingly important. Could specific parts of the brain actually influence specific aspects of behaviour? Phineas Gage became one of the strongest pieces of evidence that the answer might be yes. The area damaged in Gage's accident was mainly the frontal lobes. The frontal lobes are involved in a huge range of processes, including planning, decision-making, controlling impulses, social behaviour, and evaluating consequences. Basically, the part of your brain responsible for asking, is this a good idea, before you do something. Think of it as your brain's management department. It doesn't necessarily make every decision, but it helps organise the chaos. Like the one person in a group project desperately trying to stop everyone else from doing something ridiculous. the famous personality change. Now, this is where the story gets complicated. The version you often hear is, before the accident, Phineas Gage was polite, responsible, and respected. And after the accident, he became rude, aggressive, and completely changed. The famous quote often repeated is that Gage was no longer Gage. It makes for a dramatic story, but it also isn't quite supported by the evidence. The problem is that many details about his personality after the accident were written down years later, repeated in textbooks, and gradually became more dramatic over time. The original reports from Harlow do describe changes in Gage's behaviour. He reportedly struggled with planning, judgment, and social behaviour. However, the evidence does not suggest that he became a completely different person overnight. And honestly, the real story is much more interesting. Because the lesson wasn't damage to the frontal lobe and someone becomes a completely different human. The lesson was the frontal lobe appears to play an important role in the complex behaviours that make us who we are. And that was a revolutionary idea. Phineas Gage did not single-handedly discover modern neuroscience, but his accident gave scientists something incredibly rare, a window into how a damaged human brain could reveal what that part of the brain normally does. And over the next century, that idea would completely transform our understanding of the relationship between the brain and behavior. So what did Phineas Gage actually teach neuroscience? So after all of that iron rolled through the head malarkey, scientists argue about what changed. And textbooks turn him into one of neuroscience's most famous stories. But what did Phineas Gage actually teach us? Because surprisingly, the answer isn't simply the frontal lobe controls personality. The brain is much more complicated than that. The brain has specialized regions. Before cases like Gage's, one major question in neuroscience was whether the brain worked as one giant interchangeable organ or whether different areas had different jobs. Imagine if every employee in a company did exactly the same thing. The accountant could suddenly become the CEO, the receptionist could run the engineering department, the person making the tea could be in charge of legal affairs. But ideally, you want people with different roles. The brain works in a similar way. Different regions have different specialties, but they work together as a network. The frontal lobes aren't a magical personality center, and unfortunately, there is not a tiny manager living behind your forehead. Very disappointing. Instead, the frontal lobes are involved in coordinating complex behaviors, like considering consequences and planning for the future. Behavior can reveal brain function. One of the biggest contributions from cases like Gage's was showing scientists that changes in behavior could provide clues about changes in the brain. Before modern technology like magnetic resonance imaging scans existed, or MRI, scientists couldn't simply look inside someone's brain while they were alive. There was no brain scanner, no fancy computer images, no colourful glowing brain pictures. They had to work backwards. They observed, this person has damage in this area, they have difficulty with this behaviour, maybe this part of the brain helps with that ability. Basically, early neuroscience was a giant detective investigation, except instead of fingerprints, scientists were studying brain injuries. The brain and who we are. Perhaps the most fascinating thing about Phineas Gage is that his case forced scientists to think about a huge philosophical question. Where does our personality come from? For centuries, people wondered whether things like character, morality, and decision-making came from something more separate or higher up from the physical brain. Gage's injury suggested something profound. The biological organ inside our skull is deeply connected to the person we become. Our thoughts, emotions, memories, and behaviors aren't separate from the brain. They emerge from billions of neurons communicating with each other. And when the brain changes, the person can change too. Connection to modern science. Today, scientists have far more sophisticated tools than a railway accident. We can use MRI scans to examine brain structure, fMRI scans to study brain activity, genetics to understand risk factors, and computational models to investigate how brain networks work. But the basic idea remains the same. If we understand what changes when the brain changes, we learn more about how the healthy brain works. Connection to neurodegeneration. And this idea is still incredibly important today. It is one of the reasons studying neurological diseases like Alzheimer's disease, Parkinson's disease, is so important. When certain brain cells become damaged or die, scientists can learn which processes those cells were responsible for. For example, in Alzheimer's disease, researchers are investigating how changes involving proteins like amyloid and tau, inflammation, and cellular energy systems affect the brain. The goal isn't just to understand disease, it's also to understand what the brain needs in order to function. The myth versus reality. So, if we had to summarize Phineas Gage's story, the myth is that an iron rod went through his head and turned him into a completely different person overnight. The reality is that a brain injury changed some aspects of his behavior, helping scientists discover that the frontal lobes are involved in complex human functions. And honestly, the real version is much cooler, because the lesson isn't that one accident magically unlocked the secrets of the brain, the lesson is that every brain tells a story. And sometimes, a single person's experience can change the way we understand ourselves. Phineas Gage never intended to become a neuroscience legend. He was simply doing his job on a railway construction site in Vermont. But his accident gave scientists one of the first major clues that the brain is not just an organ that keeps us alive. It is the foundation of how we think, behave, and ultimately experience the world around us. Did one guy's freak accident suddenly reveal every secret of the human brain or even frontal lobes? No, the brain is far too complicated for that. But did Phineas Gage change the direction of neuroscience and propose new questions and advances? Absolutely. And that idea became one of the foundations for the birth of modern neuroscience, which is why stories like Phineas Gage's still matter today. Because understanding what happens when the brain goes wrong helps us understand how we might protect it. And that is the same reason researchers study neurodegenerative diseases the way they do. From damaged brains, we learn about healthy ones. So, well done, Phineas, for sacrificing your skull for us.